let's talk about solving exponential equations. Exponential equations are equations where basically you've got an x in your exponent, and we need to figure out what is the exponent that gets us from our base to our answer. So they look something like this. There's a few different ways to work with exponential equations. We have things that are called logarithms that are created specifically to help you solve exponential equations, but we're going to go through an approach that allows you to solve these without using those logarithms. And that is just kind of a more logical approach. So in this one, I've got 5 to the power of x equals 25, and it's exponential because x is in the exponent. What I'm going to do is use a property that says if I have a base and it's raised to a power, and that equals another base that's the same raised to a power, well, those exponents have to be equal to each other. It doesn't make sense to have the same base with different exponents if the two things are equal. So x would equal a. We're not dividing out the b, we're just using logic to say it's really the only thing that makes sense. So let me go ahead and apply that over here. If I rewrite my 25 as a 5, I can break it down into 5 squared. So now looking at this, I have 5 to some power is equal to, it is the same as 5 squared. Well, if they're the same, then the only number that we could possibly put in the x spot is that 2. So I can use logic to say x has to equal 2. We're not dividing by the 5s. We're just using our logic to say it's the only possible answer. Okay, let's go ahead and go through a few more. These ones are going to require a little bit more thinking, kind of a lot more thinking. Number 1. I've got now a fraction on the left, 1 over 49, and that equals a whole number to the power of x. So I want to write these two things as the same base if I can. I notice that 7 can't really be broken down. It's a prime number, so I'm not going to be able to write it as something to a power gives me 7. But 49, if I think about the factors of 49, I know there's 7 times 7. So I could write this as 1 over 7 squared is equal to 7 to the power of x. So at least we're a little bit closer. At least we now have 7s on both sides. But on the left, our 7 is in the denominator. What I'm going to do is use our properties of exponents that says negative exponents will move your base to the other side of the fraction. So if I want to move my 7 up, I can do that. I can move it to the numerator, but now I need to find a way to tell you it doesn't belong there. And I do that by just making my exponent negative. And whenever you move, you multiply by what's already there. So there's already a 1 here in the numerator. So I just multiply by 1, but I don't really need to write that because I'm just multiplying by 1. So this is just 7 to the power of negative 2 equals 7 to the power of x. Now that I have the bases matching, I can use my logic to say, well, the only thing that makes sense is that x equals negative 2. So that is my solution to this equation. Okay, let's do it again. Number 2, I need to rewrite my 8 and my 4 as the same base. If I look at 8, I can't break it down as a power of 4. 4 times 4 does not equal 8. So I'm not going to use 4s to rewrite my 8. So how do I make them the same base then? Well, we can change both the 8 and the 4. I know that 8 is 2 times 2 times 2. So 8 to the power of x plus 3, I can take that 8 and rewrite it as 2 to the power of 3. And then on the right-hand side, I've got 4 to the power of 3x, and I know that 4 can also be written as a power of 2. That's 2 squared. So I'm allowed to change both sides because the value is still the same. I'm just changing the way it looks. Now, powers of exponents say if you have a power on a power, we multiply. So I need to take this 3 and distribute. 2 to the power of 3x plus 9. And then I multiply 2 and 3x to get 2 to the power of 6x. My bases are the same, so I use my logic that says the exponents must be equal. So I now write this equation, 3x plus 9 equals 6x, and I solve. And I find that x equals 3. Okay, one more. This one's a combination of the last two problems. First, one of my bases is a fraction, so I'm going to use negative exponents to bring that up to the numerator. Secondly, I need to rewrite both bases because 125 cannot be raised to any power to get you 625. So I'm going to break them both down. And I happen to know that 625 is a power of 5. So let me rewrite that 625 as 5 to the power of 4. 5 times 5 times 5 times 5 is 625. And then on the left, I need to rewrite this as a power of 5. So let me start with just the 125. 125 is 5 to the power of 3. Now it's in the denominator. I need to bring it to the other side so that my bases can match. So I'm going to bring that up to the numerator and make my exponent negative because it doesn't belong in the numerator. It actually belongs on the bottom. So that negative is necessary to tell us where this thing is supposed to be. And then I have 2x plus 3 equals 5 to the power of 4x minus 1. And use the power of powers to simplify. So I distribute my negative 3. And I distribute the 4. And now, since my two bases are the same, my exponents must be equal. So I take these two exponents and write a new equation where they equal each other. And now I just solve. So x is negative 1/2. So that's a little bit about solving exponential equations. I hope you had some fun. Thanks for watching, and I'll see you next time. Bye.